Hello everyone, good evening. So here we shall solve some KCET previous year questions on the chapter Conic Sections. So if you have any questions regarding any steps of the solutions or any other doubts if you are having, then please write us in the comments section. We shall obviously clarify them in the subsequent videos. And if you feel that you have more difficulty in any of the chapters, then please mention the name of that chapter in the comments section. Then we shall give more priority on it and solve more and more questions on that chapter, which will be helpful for your KCET exam. Also, some homework questions on every chapter will be uploaded in the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. So here, so we shall start off with the very first question of the chapter Conic Sections. So here it is told that x is equal to 4 into 1 plus cos theta and y is equal to 3 into 1 plus sine theta. So we have to find that these two are the parametric equations of which curve. These are the parametric equations of which curve. So therefore from here we can see that x by 4 that is equal to 1 plus cos theta and y by 3 that is equal to 1 plus sine theta. So therefore we can say that cos theta equal to x by 4 minus 1, which is equal to x minus 4 by 4, and similarly sine theta will be equal to y by 3 minus 1, that is equal to y minus 3 by 3. Now therefore we know that sine square theta plus cos square theta that is equal to 1. So therefore we can write x minus 4 by 4 whole square plus y minus 3 by 3 whole square that is equal to 1. So therefore we can say that x minus 4 whole square by 16 plus y minus 3 whole square by 9 that is equal to 1. So option D is the correct answer. Then it is told that if the distance in between the foci and the distance between the directrices of the hyperbola are in the ratio 3:2, then A is to B is. So if the distance between the foci and the distance between the directrices of the hyperbola, okay, so if one hyperbola, if I have this, so these are the two directrices and this is the y-axis, and these are the two foci. The foci are AE, 0 and minus AE, 0, and the directrices are x equal to A by E and this is x equal to minus A by E. So now therefore we can say the distance between the foci, that will be equal to 2AE, and the distance between the directrices, of the hyperbola will be equal to 2A by E. Now therefore the ratio of the distance between the foci and the distance between the directrices, so that will be 2AE by 2A by E. So that will be 2A will cancel, so this will be E square. So E square is equal to 3 by 2. So now therefore E is equal to root over 3 by 2. So now for this hyperbola, the eccentricity E is given as square root of 1 plus B square by A square. So now therefore square root of 1 plus B square by A square that is equal to root over 3 by 2. So therefore we can say 1 plus B square by A square equal to 3 by 2. Therefore B square by A square that is equal to 3 by 2 minus 1, which is equal to 1 by 2. Now therefore B square by A square that is equal to 1 by 2. Therefore B by A that is equal to 1 by root 2. So A by B will be equal to root 2 by 1. So the answer is root 2 is to 1. So option A is the correct answer. is told the eccentricity sorry, the ellipse x square by 25 plus y square by 16 equal to 1, and the hyperbola x square by 25 minus y square by 16 equal to 1 have in common center only or center foci and directrices or vertices, so that we have to find. So therefore the vertices of the ellipse and the hyperbola that we have to find. So the vertices of the ellipse, that is plus minus a comma 0. So therefore here a is square root of 25, which is 5 for both ellipse and the hyperbola, and b is equal to square root of 16, that is 4 for both ellipse and hyperbola. So the vertices is plus minus 5 comma 0 here, and here also plus minus 5 comma 0, and the center is obviously 0 comma 0 for both ellipse and hyperbola, and the and here the eccentricity for the ellipse, that will be equal to square root of 1 minus b square by a square, so that is square root of 1 minus 16 by 25, which is 9 by square root of 9 by 25, which is 3 by 5, and eccentricity for the eccentricity for the ellipse, say it is e1, and eccentricity for the hyperbola, let's say it is e2, so that will be square root of 1 plus b square by a square, so that will be equal to square root of 1 plus 16 by 25, so that is root over 41 by 25, so it is root over 41 by 5. So therefore AE, the foci AE is not same. A into E for the ellipse will be equal to 3, and for the hyperbola A into E2, that will be equal to root over 41, so they are not same. Then the directrices, which is a by e1, that will be equal to 5 by e1, that is 25 by 3, and a by e2, that will be equal to 25 by 41, so they are not the same. So therefore the foci are plus minus, this is 3 comma 0 here for the ellipse, and for the hyperbola it is plus minus root 41 comma 0. And the directrices are, for the ellipse it is plus minus, so which is x equal to plus or minus 25 by 3, and for this it is x equal to plus or minus 25 by root over 41, so they are not same. So foci is not same and directrices are not same, so only the center and the vertices are the same. So option D is the correct answer. Sorry. Foci are, this is a to e 1 plus b square by a square So option D is the correct answer. Then here it is told, if the length of the tangent from any point on the circle x minus 3 whole square plus y plus 2 whole square equal to 5r square to the circle is 16 units, then the area between the two circles is square units is okay. So the center of both the circles is the same actually, so they are actually concentric circles, their center, so they have the common center, so their common center is 3 comma minus 2, so 3 comma minus 2, let's say this point is 3 comma minus 2, then the radius of the first circle is r and the radius of the second circle the radius of the second circle is root 5r. So therefore we have to find the area of the region in between the two circles. Area of the region in between the two circles. So this area that would be equal to, this is pi r square, pi into root 5r whole square minus pi r square. So that will be equal to 5 pi r square minus pi r square. So that will be equal to 4 pi r square. 4 pi r square. Okay. So then here it is told that the length of the tangent from any point on this circle to the circle, this is 16 units. So now length of the tangent from any point on this circle to this circle. Length of the tangent from any point on this circle to this circle. So therefore we know that the length of the tangent, so if their centers are same and their radii are not same, then we can say that for both the circles only the constant term will be different. So it means that if the equation of a circle is x square plus y square plus 2gx plus 2fy plus c equal to 0, then for the other circle also this g and f will remain the same since their center is common. Since the center here, the center will be given as center is minus g comma minus f, and the radius is given as square root of g square plus f square minus c. So length of the tangent will be given as root over c1 minus c if the other circle, if the equation of the other circle is x square plus y square plus 2gx plus 2fy plus c1 equal to 0. So now c1 minus c, so here c1, so here c1 will be 5 which is 9 plus 4 minus 5r square, and c is 9 which is 9 plus 4 minus r square. So therefore root over c1 minus c, that is actually, sorry, this is c, this is c1, so c1 minus c, so that will be square root of 5r square minus r square, that is equal to 4r, which is 2r, so 2r is equal to 16, so therefore r is equal to 8. So therefore the area of the region will be 4 pi r square, so 4 pi into 8, that is equal to 8 square, so this is 64 into 4, 4 is 16, 16, 4 say 24, 256 pi is the required area. So it means that none of the options are correct. then it is told that the circles ax square plus ay square plus 2gx1 plus, okay, this and this cut orthogonally. So, okay, so they cut orthogonally if, okay, here the rule is that if I have one circle and if I have another circle and they cut orthogonally, okay, so the rule is that if the circle x square plus y square plus 2gx plus 2fy plus c equal to 0 and the circle x square plus y square plus 2 g dash x plus 2f dash x 2f dash x plus c dash equal to 0 cut each other orthogonally, then we have that 2 2 into g dash plus f dash, that is equal to c plus c dash. So this is the rule. So therefore here the circles, this ax square plus ay square plus 2g1x plus 2f1y plus c1, that is equal to 0, and bx square plus by square plus 2g2x plus 2f2y plus c2, that is equal to 0 will cut orthogonally if, so I can say that here, so the first circle we can write it as x square plus y square plus 2g1 by a into x plus 2f1 by a into y plus this is c1 by a, that is equal to 0, and the other circle can also be written as 2x square plus y square plus 2g2 by bx plus 2f2 by by plus c2 by b equal to 0. So now therefore they cut orthogonally if they will cut orthogonally if 2 into g1 g2 means g1 by a into g2 by b g dash plus f dash, that is f1 by a into f2 by b, that is equal to c1 by a plus c2 by b. Okay, so here we can say it will be 2 into g1 g2 plus f1 f2 it will be equal to ab by ab into this will be b BC1 plus AC2. AB and AB will cancel. So therefore it is 2 into G1 G2 plus F1 F2, that is equal to BC1 plus AC2. BC1 plus AC2. So option B is the correct answer. Then it is told the equation of the common tangent of the two touching circles are, equation of the common tangent. Equation of the common tangent of the two touching circles. So two circles are touching each other, then the common tangent of the equation of the common tangent of the two touching circles. So let that point be a comma b, where the two circles are touching each other. So therefore if we solve the equation of these two circles, then we can find those points A and B. And so now therefore if we solve these two circles, that will be x square plus y square equal to 6x plus 12y plus minus 37, and here it is x square plus y square, that is equal to 6y minus 7. So these two are equal. So therefore that will be 6x plus 12y minus 37, that should be equal to 6y minus 7. So it means that 6x plus 6y minus 30, that should be equal to 0. So therefore we can say that x plus y minus 5, that is equal to 0. So therefore a comma b should lie on this straight line. So therefore the equation of this common tangent is x plus y minus 5 equal to 0. So option C is the correct answer. Since y, simply the rule is that the equation of the common tangent can be obtained by using simply the equation of the common tangent is s1 equal to s2, where s1 is the equation of the first circle and s2 is the equation of the second circle. So if we solve these two, then we will get the equation of the common tangent. Okay, then it is told that the equation of the parabola with vertex at minus 1 comma 1 and focus at here. So the parabola is somewhat like this, where the vertex is at minus 1 comma 1 and the focus is at 2 comma 1. So therefore the vertex is here. Therefore we can find the equation of the directrix, and this is the vertex, this is the focus. Then we can find the point at which the directrix will intersect the axis of the parabola. So this is the axis of the parabola, equation of the parabola's axis. So therefore the equation of the axis of the parabola, equation of the axis of the parabola is given as, it will be y minus 1, that is equal to m, which is 1 minus 1, x2 minus x1 to y x plus 1. So it means that y minus 1, that is equal to 0. So it means y is equal to 1. This is the equation of the axis. Now therefore this is the midpoint. So now therefore this point, let's say it is x1 comma y1. So this is the vertex, is the midpoint. So let's say this point is P. Let's say it is A. So therefore x1 plus 2 by 2, that is minus 1, and y1 plus 1 by 2, that is equal to 1. So therefore x1 plus 2, that is equal to minus 2. So therefore x1 is minus 4, and y1 plus 1, that is equal to 2. So therefore y1 also is equal to 1. So therefore this point is minus 2 comma 1, and this equation is y equal to 1, and this straight line is x equal to minus 2, x equal to minus 2. Now therefore the equation of the parabola can be obtained by using the formula, that is pf equal to pm. Pf equal to pm means that at any point the length pf will be equal to pm. So pf that will be equal to x minus 1 whole square plus y minus x minus 2 whole square plus y minus 1 whole square, square root of that, that is equal to pm. It is mod of x plus 2 by 1, which is any arbitrary point on the parabola. Any arbitrary point on the parabola is taken as x comma y. So then if you square on both sides, then this will be x minus 2 whole square plus y minus 1 whole square, that is equal to x plus 2 whole square. So this will be y minus 1 whole square, that is equal to x plus 2 whole square minus x minus 2 whole square. So that will be equal to y square plus 1 minus 2y, that is equal to, so this is 4ab, so 4 into x into 2. Since a plus b whole square minus a minus b whole square is 4ab. 4ab. So therefore we will get y square minus 2y plus 1, that is equal to 8x. So therefore we can say that y square minus 8x minus 2y plus 1, that is equal to 0. It's minus 2 whole square, okay. Y square plus 1 plus 2y, sorry, minus 2y, that then plus x square plus 4 minus 4x, that is equal to x square plus 4 plus 4x. X square will cancel, and 4 will cancel, so that is 8x. So it is y square minus 8x plus 1 that is equal to 0. So here it means that none of the options are correct. Okay, so hope you have understood the solutions of of these questions, and the remaining questions on conic sections we shall solve in the next part of this video. So hope you have understood. So please install our Sapience education application, whose link has been provided, where some